Welcome to T2 Day 9 of Honors Precalculus. We're going to continue using multiple angle identities. So let's use one of these multiple angle identities to prove that sine of 2u is equal to 2 sine u cosine u. So what are we going to do? Well, sine of 2u is sine of u plus u, and we know the sine of a plus b is sine cosine plus cosine sine. So in this case, it's just going to be u's in all of these places. So what you end up with is sine u, cosine u, plus cosine u, sine u, and these two things are the same. So there are two of them, so the answer is indeed 2 sine u, cosine u. Yay! What about this one? Well, we're going from left to right, and again, we're going to take cosine of 2u, and we're going to turn it into cosine of u plus u. So what do we use here? We use cosine of a plus b is equal to this. The key here is that there's a minus sign right there. So what that means is you end up with cosine u minus sine u, because in this case a and b are both just u. So you end up with cosine squared u minus sine squared u. And it might seem like you can do something with this. You can't. It's cosine squared plus sine squared that we know equals 1, not this. So you're done at this point, which is good because it's exactly what we wanted. So let's keep playing around with these identities. So we know from above that cosine of 2u is equal to cosine squared u minus sine squared u. We also know that cosine squared plus sine squared is equal to 1, which tells us that sine squared is equal to 1 minus cosine squared. What this allows us to do, and remember this is just shorthand, we could plug this in right here to get the second one, which would be cosine of 2u is equal to, this stays the same, and we're going to subtract from it 1 minus cosine squared u. That's another identity we can do here. So what does that mean? You end up with cosine, so 2 cosine squared u plus 1, because this negative distributes. Now similarly, we also know that cosine squared is equal to 1 minus sine squared. So what we can do there is plug that one in to here to get another one, which would be cosine of 2u is equal to, now it's the substitution, 1 minus sine squared u minus sine squared u, like this. So that simplifies to 1 minus 2 sine squared u. So these are identities you need to know. So in all three cases, cosine of 2u is equal to, here's the first one, here's the second one, here's the third one. So how do we go about proving this identity here? The general idea is start with the bigger side and move to the shorter, smaller side. So we're going to go from left to right here. What you'll notice here is this is just cosine squared theta squared minus sine squared theta squared. This is the difference of squares. So we can factor it into, it's going to be the first thing, so cosine squared theta plus sine squared of theta times cosine squared of theta minus sine squared of theta. And then you might try to factor some more. You got to be careful here, because let's just see what we notice here. Well, look at this. Look familiar here? Cosine squared plus sine squared. Excuse me, I meant to highlight the other one. Cosine squared minus sine squared is right here. So this is cosine of 2u right here. So cosine of 2u. And then we still have cosine squared plus sine squared. Well, what's that? We don't need to factor, because we know that that by definition is Babylonian identity 1. So this turns out to be cosine of 2u, or in this case 2 theta. I don't know why I went to u there. Theta cosine 2 theta. I went to u because it was written up there like that. Cosine of 2 theta, which is what we wanted to prove. Yay! So again, this is the difference of squares, this is an identity from above, and this is the Babylonian identity, the first one. So how do we solve this equation for all values of t in radians exactly? So what we're going to do here first is we're going to use an identity and turn this, using the identity we have above, to turn this into something without 2t. This is equal to, by definition, 2 sine t cosine t from above, and the right hand side stays the same. We then subtract cosine t, and we get 2 sine t cosine t minus cosine t is equal to 0. And now what do you have in both pieces? You have a cosine t in both pieces, so you can factor that out. So you have cosine t times 2 sine t minus 1 is equal to 0. So there's two ways in which this can be true. Either cosine t is equal to 0, or 2 sine t minus 1 is equal to 0. Both of them have the opportunity to solve this equation. So what does that mean? It means that t is over here, and I'll stay in red here just to stay consistent. T over here is equal to cosine inverse of 0. And remember, when we do that inverse, we end up with two answers here. The cosine of what is 0? The cosine of what is 0? Well, that's going to be two things. That's going to be t is equal to pi over 2. And remember, it rotates. The period is every 2 pi. And it's also at 3 pi over 2. And it also is there. So there were two. Both. Oh, sorry. Yeah. Well, 3 pi over 2 is the same thing as negative pi over 2. 3 pi over 2 is the same thing as negative pi over 2. For sine over here, we have to do a little bit of work. We have 2 sine of t is equal to 1, so sine of t is equal to 1/2. So we know that t is equal to sine inverse of 1/2. And when we do that out, sine inverse of 1/2 is pi over 6. So you have pi over 6 plus 2 pi n. But then you have to do pi minus pi over 6 to get the other t value. So the other t value, the one that's going to go right here, will be t is equal to 5 pi over 6 plus 2 pi n. Remember over here, if we had pi over 2, the other one just is negative pi over 2. But for sine, you subtract it from pi. So this one's pretty involved here. We can't really do anything with the left yet. So we're going to solve for this, meaning we're not proving it, we're solving, so we can use both sides. So another way to write sine squared is just going to be the sine of t over 2, the whole thing squared. And we know that relationship-wise, we know that cosine squared plus sine squared is equal to 1. So we know that sine squared is equal to 1 minus cosine squared. So using that would tell us this, but the problem with this right here, the problem with this is that we have t over 2 and we have t here. We want it to be the same thing. We want to get rid of that. So let's look at the identities we have, and one of them might be helpful. So this is correct right here, but it doesn't help us. So are there any other identities we've used? Well, there's one right here which is super helpful. There's one right here which is super helpful, which is this one right here. Cosine of 2 theta is equal to 1 minus sine squared of theta. So it tells us that cosine of 2 times theta is equal to 1 minus 2 times sine squared of theta. And this is helpful because we can just make a substitution here. Let theta equal t, let theta equal t over 2. This is true for whatever you plug in for theta. So if you do that, you get cosine of 2 times t over 2 is equal to 1 minus 2 sine squared of t over 2, like this. The 2's cancel there, and you get cosine of t is equal to 1 minus 2 sine squared of t over 2. And look what we have. So what does that mean sine of t over 2 is? Well, let's move it to the other side. So you get 2 sine squared of t over 2 equals 1 minus cosine t. So this means that sine squared of t over 2 is equal to 1 minus cosine t over 2. And to get rid of this square here, we need to take the square root. So this tells us that sine of t over 2 is equal to the square root of 1 minus cosine t over 2. Why is this helpful? Well, it means we can keep the left hand the same, and it's 2 times what we just found out. What we just found out was that sine of t over 2 is the square root of 1 minus cosine t over 2. The square root of 1 minus cosine t all over 2, and that doesn't look very nice, but this whole thing is being squared. And when you square a square root, it goes away. So you get this is equal to 2 times 1 minus cosine t all over 2. You simplify this some more, and you get sine squared t is equal to 2 minus 2 cosine t all over 2. So you get sine squared of t is equal to 1 minus cosine of t. And we know from our other identity that this right here is equal to 1 minus cosine squared of t. We want to get it in one trig function, 1 minus cosine t. And now we put it all on the same side. The 1's cancel, add the cosine, and what do you end up with? I want to add the cosine squared, so it's going to end up with 0 equals cosine squared t minus cosine t. And this you can factor out a cosine from, so you get cosine of t times cosine of t minus 1. So this is true either when cosine excuse me, of t is equal to 0, or when cosine of t minus 1 is equal to 0. And this is going to be right here when t is equal to pi over 2 plus pi n. You can do this because you know it overlaps a little bit, so you can do both. I mean, cosine inverse of 0, the cosine of what is 0, it's pi over 2 and negative pi over 2. But if you write both of these out, they actually overlap, so you can write it as 1. But then over here, you get cosine of t is equal to 1. When is cosine equal to 1? The only place cosine is equal to 1 is when t is equal to 0. So it's going to be 0 plus 2 pi n. Positive and negative 0 is 0. So you have two answers here, one answer there. And there's technically two here, but it really is just one. This is a bunch of work. This is a bunch of work. And this right here is something that's good to know, but this is about as complicated as it gets.